Hello, everyone. Welcome to the Mechatronics class. I am your teacher, Huang Huachan. The motion control functionality of the S7-1500 supports the positioning and movement of accents, making it an important component of the integrated features of the S7-1500 series CPU. The motion control functionality supports various process objects, including rotary accents, positioning accents, synchronized accents, and external encoders. We will cover the following topics. Learning objectives. 1. Master how to utilize the motion control functionality of the S7-1500, particularly the setup of positioning accents, to drive the MCD model. 2. Learn how to use the control panel to operate the motor's forward and reverse rotation. Now, let's look at the specific operational steps. Now we will demonstrate the specific operational steps. First, open the servo motor model. Click on the application module in the ribbon. Then select the drop-down arrow under More and click on Mechatronics Concept Designer to enter the MCD module. The home page displays the main commands of the MCD module. Since only the motor shaft is able to rotate, we need to set the motor shaft and the components on it as rigid bodies, ensuring they are both set as a single rigid body. Click OK. Under the Mechanical section, click on Basic Hinge Joint and choose Hinge Joint from the dialog box. Set the motor shaft as a self-rotating joint. Select the motor shaft as the connected body and leave the basic body unselected. Since the body of the motor is stationary, we can consider the motor shaft to be performing a self-rotational motion relative to the ground. The specified vector should be along the axis of rotation, and the anchor point must be correctly chosen as the rotation center. Click OK. Once completed, select Position Control under the Motor section. The object selected will be the rotary joint set earlier. Choose the path option to follow the shortest path, and there is no need to set the target or speed, both should be 0. Because we are using a virtual axis to control the speed and position of the motor shaft, we need to create 2 signals to connect with the PLC. In the Motor menu, under the Symbol Table drop-down, click on Signal Adapter. Create 2 signals for the motor's position control, one for the motor shaft speed and one for its position. We will start with the speed settings. Copy the existing signal and check that its data type is double integer. Click on Add Signal to create a signal for controlling the motor shaft speed. Set the data type to double and the dimensionality to none. The formula below will associate the 2 signals, one for the signal and one for the electromechanical object, by assigning a related formula. Press Enter. It is recommended to use copy and paste for this step, as manual entry is prone to errors. Next, create the second position signal for controlling the motor shaft's position. Click on Add Parameter. Check the parameter option, and then copy it to create an input signal for position. The data type and dimensionality should match those of the speed signal. Once copied, ensure it's categorized as an input signal. Then confirm to complete the signal creation and save. The initial setup in MCD is now complete.